Hello everyone. Today we will discuss a very important chapter from physics, which is known as the gravitation. And we can say that it is one of the very important chapter from physics. And from the earlier days, we have learned that surrounding objects, that means there are different number of objects surrounding us, maybe some small objects, maybe some large objects, and always we have learned that every object attracts the other bodies with a particular force of attraction. That means, and it's also applicable for our Earth as well. That we have seen from the earlier classes that Earth attracts all the other bodies towards its center. So this concept is coming from the chapter gravitation, and the particular force, gravitational force, which we say, it is one of the very classical forces from physics. That means there are few classical forces which are available, which we consider them as the classical forces in physics. Like one is the electrostatic force, one is magnetostatic force. Similarly, one of the forces is gravitational force. So today we'll start from the gravitational force. We'll try to understand some things regarding the gravitational force. The topic is starting from the very fundamental law, which is known as the Newton's laws of gravitation. Okay. So the law is saying that suppose there are two objects, one of mass m1 and other of mass m2, and which is separated by a small distance r. Okay. Then according to this particular law, according to gravitational law, it is always attractive in nature. That means according to the concept of gravitation, it is saying that with this particular force, every object is attracting the other objects which is surrounding. Okay. So here also from the figure that m1 is a particular body, so it is also attracting the m2 body. Okay. So that is a particular force of attraction. So that force is known as the gravitational force. Okay. So according to Newton's law, the gravitational force F will be directly proportional to the product of the masses, and it will be inversely proportional to the square of the distance between the bodies. That means the particular force with which m1 will attract m2, or similarly m2 will attract m1, that particular force will be directly proportional to the product of the masses, and as well as it will be inversely proportional to the square of the distance between the bodies. That means if the masses of the bodies will be in the increasing order, that means will be rising, then obviously the force of attraction between them will be higher. And similarly, the force has inverse dependency on the distance between the bodies. That means if we maintain a very small distance between the bodies, that means the force will be larger. And similarly, when the distance will be bigger, then the attractive force between the bodies will be much smaller. Okay. So if I just combine them, combining equate if proportional to m1 m2 by r square, or from where if I equate it, one constant will come. That constant is usually written here as capital G. The capital G is a constant which is coming here. So this G m1 m2 by r square. Okay. So this particular expression is known as the Newton's laws of gravitation. Okay. So this is known as the Newton's laws of gravitation. Okay. Where this particular constant which is coming in the expression, that is known as the universal gravitational constant. It is known as the universal gravitational constant. Okay, so we will try to understand that why this particular variable is known as the universal constant, and also the force which is actually appearing here between the bodies, that particular force is also treated as a universal force. Okay, it is also considered as the universal force. So we will try to understand why this universal term is coming here, because this particular force, what is the gravitational force is generating between the bodies, that is actually not dependent on the physical factors. What are the physical factors? That may be temperature, that may be humidity, that may be pressure. So if you rise or fall in temperature or pressure or humidity, there will be no variation on the value of capital M. Okay. Similarly, it will be a space and time independent quantity. Okay, so that means if you change the location, okay, so there will be no variation in the expression, there will be no variation in the law. And similarly, it is also a time independent equation. Okay, and also you can say that it's a central force. First of all, this particular force which is developing between the bodies, it is a conservative force and it is also a central force. It is space and time independent quantity. So all the other physical factors which are available, so that has no dependency on this particular force. Okay, so due to this, all these criteria, this particular force F is known as the universal force. And similarly, due to the same cause, the capital G term which is coming here as a constant, which is basically a proportionality constant, that capital G is also a universal constant. That means there will be no change if we change the location, if we change the time. Okay, there will be no variation in the expression of capital F as well as in the expression of capital G. Okay, so but this particular force that means I was telling about the basic classical forces, that means electrostatic force, magnetostatic force, and also the gravitational force. So among all of this, you will find that gravitational force is the least force. That means in terms of magnitude, if I arrange, then gravitational force will be the weakest force. Okay, so why it is the weakest force? Because due to the value of capital G, it's a very small value. Okay, so we will come on the topic capital G. So we have seen that E is equal to G E1 E2 by R square. So from where, if I make G as the subject of the equation, so it is coming F into R square by E1 into E2. Okay, so from here we can define the term capital G. Okay, we can define the term capital G as well as we can there will be a particular dimension, there will be a particular unit of that quantity, and as well as there will be a particular value of the capital G. Okay, so if I just see the definition part, so it's saying that if suppose if I am maintaining that in1 and in2 is equal to 1, okay, and if I also maintain that the distance between the bodies, that means in the diagram what is represented here, if it is equal to 1, then what will be the particular force which is developing between the bodies, that is equal to capital G. That means if I just convert into a statement, that means if two unit bodies, okay, two unit bodies, and they are supposed kept apart by this unit distance, then what will be the attractive force developing between them? That particular force is known as the universal gravitational constant. Okay, so what is the attractive force developing between two unit bodies whenever they are at a unit distance apart? That particular force is equal to the gravitational constant. Okay, so from here also we can calculate what will be the unit of that quantity. What will be the unit of that quantity? So if I go for CGS system, then from the expression G is equal to F R square by M1 into. So in the CGS system, F can be replaced as dyne, okay, distance that is centimeter square divided by, for the masses it is gram square. It is gram square. Okay. Similarly, in the SI system it will be Newton meter square by kg square. So these are the two units of universal gravitational constant in the CGS system and also in the SI system. Okay. Now if I go for the value, it will have a standard value. There will be no variation of the value. That means this particular law. Okay, why it is called universal law? Because you can apply this word. You can apply this law for the microscopic system as well as for the macroscopic system. That means for the atomic particles, subatomic particles, you can apply this gravitational law, and also for the heavenly bodies, like for the planets, movement of planets around the sun. Okay, in those heavenly bodies movement, we can apply also this law. Okay, so space-time independency and also the macroscopic and microscopic world, for both of them we can apply the law, and also the time independent quantity, central force, conservative force. Due to all of these criteria, and also it is a physical factors. That means your time, temperature, pressure, humidity, there will be no effect on it. Due to all of these causes, so it is a universal law. So if I write down the value of it in the CGS system, the value will be 6.67 into 10 to the power minus 8. It will be 9 centimeter square by gram square, and in the SI system it will be 6.67 into 10 to the power minus 11 Newton meter square by kg square. So it is the value of universal gravitational constant in the CGS system and also in the SI system. Okay. So if I see this expression, if I just follow